Good morning to one and all present here. Today we are going to discuss about the topic Introduction to Semiconductors. Semiconductors in everyday life. Since semiconductors itself is not sold in stores as electrical appliances, it may be hard to understand, but in fact it is used in many electrical appliances. For example, temperature sensor, which is used in air conditioners, are made with semiconductors, and rice cookers, which cook rice perfectly, use semiconductors to control the temperature precisely. CPUs that operate personal computers are also made with semiconductors. Many digital consumer products in everyday life, such as mobile phones, televisions, digital cameras, washing machine, refrigerator, and LED bulbs, are also made up of semiconductors. In addition to consumer electronics, semiconductors play a critical role or a vital role in the operation of bank ATMs, trains, internet, communication, and other parts of social infrastructure, such as the medicine network used for care for elderly, among other things. Furthermore, efficient logistic systems help save energy and promote the preservation of the global environment. The number of car-mounted semiconductor devices has been increasing steadily. Most of the semiconductors nowadays are used in car-mounted systems so that the efficiency of the working increases. There are many types of car-mounted semiconductors. Particularly, semiconductors are mostly used in advanced driver assistance systems, which is also called as ADAS. More semiconductors are expected to be used. In this way, semiconductors helps us to live comfortable lives.
Hi, my name is Sadanand Singh, and I am going to represent the topic semiconductors devices. So, the most used semiconductors are silicons, germanium, and gallium arsenides. Some of the semiconductor devices are LED lights, light emitting diodes. These are the semiconductor devices that emits light when current passes through it. Next, solar cells. Solar cells are the devices that converts sunlight into electricity used in solar panels. And electronic musical instruments. Digital pianos use semiconductor devices to generate and process the sound signals. Security systems. Security systems such as cameras use semiconductor devices such as sensors to detect and respond to security threats. Semiconductor chips. Semiconductor chips are very tiny electronic devices that are made from materials like silicon. They are used in a lot of things like computers, TVs, phones. The chips are stored and process the information in the digital form.
Hello everyone, I am Satish Kumar and I will be discussing about the topic classification of materials based on the energy band. First, there are mainly three classifications: conductors, insulators and semiconductors. Conductors are those class of materials which allow electric charges to pass through them easily. Example, copper and aluminium. In case of conductors, there is no energy gap between the valence band and the conduction band. The energy gap is zero. So even in room temperature, some of the electrons from the valence band move towards the conduction band. So even when small voltage is applied, the electric current passes through them. Now, the second classification. The second one is insulators. Insulators are those class of materials which do not allow electric charges to pass through them. In insulators, there is a large energy gap between the valence band and the conduction band. It is of up to more than 5 electron volt. As a result, even while providing external energy, the valence electrons are not able to jump to the conduction band, and that is the reason why insulators cannot conduct electricity at room temperature. Third classification is about. Hello everyone, I am Satish Kumar and I will be discussing about the.
So, so
Hello, my name is Sanat and I'm here to discuss about types of semiconductors. There are basically two types of semiconductors, intrinsic and extrinsic semiconductors. Taking intrinsic semiconductors into picture, these are pure semiconductors and they have low conductivity at room temperature. whereas on the other hand, extrinsic semiconductors are impure or doped semiconductors and have high conductivity at room temperature. In intrinsic semiconductors, number of holes is equal to number of electrons, whereas in extrinsic semiconductors, number of holes is not equal to number of electrons. Examples for intrinsic semiconductors are pure elements like silicon, germanium, etc. And for extrinsic semiconductors, examples are silicon doped with another pentavalent or trivalent elements. Thank you. Passing on to Harush.
So hello guys, I am Arush Kauda. I am here to explain about the types of extrinsic semiconductor. Types of extrinsic semiconductor, there are two types. One is N-type semiconductor and other one is P-type semiconductor. So coming to N-type semiconductor, when a tetravalent atom such as silicon or germanium is doped with a pentavalent atom, N-type semiconductors are formed. Um, when a tetravalent atom such as silicon or germanium is doped with a trivalent impurities, p-type semiconductors are formed. So in n-type semiconductors, the four of the electrons of pentavalent atom bond with the four of neighboring silicon atoms, and the fifth one remains weakly bound to the parent atom. Whereas in p-type semiconductor, a fourth atom of a tetravalent atom is free and a hole or vacancy is generated in trivalent atom. So coming to n-type semiconductor, they are also known as donor atom due to the presence of additional electron. Here in p-type semiconductor, they are known as acceptor atom because due to the presence of additional hole. In n-type semiconductors, majority charge carriers are electrons and minority charge carriers are holes, whereas in p-type semiconductor, majority charge carriers are holes and minority charge carriers are electrons. In n-type semiconductor, pentavalent impurities are added, whereas in p-type semiconductor, trivalent impurities are added. In n-type semiconductor, Fermi energy level is present near to the conduction band than the valence band. So whereas in p-type semiconductor, Fermi level appears close to the valence than the conduction band. In n-type semiconductors, the doped impurities such as like pentavalent impurities are group fifth element. Example arsenic, antimony, bismuth, etc. Whereas in p-type semiconductor, the doped impurities are of the like trivalent impurities are of third group. Example boron, gallium, indium, etc. So thank you. Next, I'll pass on to Roshan.
Hi sir, my name is Roshan Zubair and I am going to discuss about future scope of semiconductor industries in India. Why the raising opportunities of in semiconductor market is due to raising demands for consumers, tremendous growth in electric vehicles, and raising automation in manufacturing industries. India's goal is to become world leader in semiconductor industries. Domestic semiconductor consumption is expected to cross 80 billion US dollars in 2026. Clearly, with the economy improving in the country over the past few decades, the consumption of electronic goods has also increased. Today, electronics and semiconductors are so pervasive that every product has some portion of electronics and semiconductors. As our economy continues to grow in the future, the market also the market of electronics and semiconductors will grow only in our country. The key players in semiconductor market in future are Diotech, Cisco and Aura. Thank you.